All right, this is going to be worksheet 2-5. These are the video solutions. All right, so let's go and look at the rules that we have for review. We've already learned the power chain rule, and in this last lesson we just learned the exponential chain rule and the logarithmic chain rule. So we have exponent, or e-house, we have log house, and power house in this lesson, or in this assignment. Here we go. So our first problem, we have our equation here. Let's go ahead and solve it. So our outer function here is 3e to the power of something. So the derivative of the outer is 3e to the power of that same something. What's the inner? Inner is 4x. That's the stuff that's inside the parentheses. And the derivative of the inner, or the dinner, here is 4. So just go ahead and multiply daughter by dinner. Daughter is 3e to that something. That something is 4x. And our daughter is 4. So our final answer, this is equal to 12 times e to the power of 4x. All right, go ahead and pause the video. Make sure you have done number 2. And here we go. So outer is negative 1/4 e to the power of something. So daughter is negative 1/4 e to the power of something. It's quite repetitive now. It's the same exact thing. Outer and daughter are the same thing when I'm in e-house. So inner is just x. It's the thing inside the parentheses. So dinner is 1. Derivative of x is 1. So multiply daughter by dinner. Make sure you do that. So daughter is negative 1/4 e to the power of whatever, and that happens to be x, times dinner, which is 1. So my final answer is just negative 1/4 e to the x, which is the same exact problem that I started with. All right, moving on to number 3. Make sure to pause the video before each problem that I work on so I don't give anything away. All right, so outer is 2e, inner is x. So just like our last problem, this is just going to be 2e to the power of x. All right, number 4. So this is going to be, what house am I in? Am I in power house, log house, e-house? It's only those 3 options for this assignment. And you should say, okay, this is power house. Power house means I'm going to multiply the exponent down. So negative 2 times 2 is negative 4. And then I subtract 1 from the power. Number 5. So f prime of x, in this case, f prime of x, or the derivative of this function. So this one's maybe a little bit hard to see, but the outer is negative 3/2 e to the something. So daughter here is negative 3/2 e to the something. That something is 2x. And then what's inner? Inner is 2x. So dinner, multiply by dinner, never forget to multiply by dinner, is times 2. And then you can see here that the 2 and the 2 cancel out, and I'm left with my final answer of negative 3e to the power of 2x. All right. Again, if I do make mistakes in this video, go ahead and tell me, and you guys can get some extra credit. It's whoever tells me first. 1 extra credit point on the homework. Number 6. So my outer is negative e, so rewrite the outer, that is my daughter, and my dinner, so rewrote my equation for my daughter, and my dinner is going to be the derivative of negative x, so times negative 1, so this is going to be equal to e to the power of negative x. Numero 7, here we go. We have to rewrite the equation. We're in e-house. E-house means I'm rewriting the equation, and I multiply by dinner. Inner is negative 5x, so dinner is negative 5. My final answer is negative 5 e to the negative 5x. All right, number 8, what house are we in? We are in power house. So power house means I'm going to do the same rule as I did in number 4, where I multiply that exponent down and then subtract that exponent by 1. So if I do that, f prime of x, this is going to be equal to 2ax to the power of 1, and I'm not even going to write that 1, 2ax. There we go, done. Number 9, We are in what house now? E house, log house, power house. You should see we're in E house. We see the E there. So the outer is just the function again. D outer, or doubter, is e to the power of 2/3 x. And then I multiply by dinner. Never forget to multiply by dinner. And dinner is 2/3. So my final answer is just 2/3 e to the power of 2/3 x. So I'll rewrite that down here. 2/3 e to the power of 2/3 x. All right, number 10. So what house are we in? We are in power house. So power house means I'm multiplying the 3 down. 3 times -2 is a -6 x, and then the 3 turns into a 2 because I'm subtracting 1. So my final answer is -6x squared. Number 11, and whenever I'm doing the derivative, the first question is always going to be, what house am I in? So that question is now going to be answered by saying we are in E house. All right, so I basically rewrite E house and then take that times dinner. So rewrite E house for e to the power of -x over 4, and then multiply by dinner. Dinner is -1/4. So my final answer here becomes, and I should write f prime is equal to all of this. I'm just going to say f prime is equal to all of this. So my final answer is -e to the -x over 4. All right, number 12. Find the derivative of this guy. What house are we in? We're in power house. So power house means multiply the 3 down. And I'm going to go ahead and skip a step here. If I multiply that 3 down, I know it's going to be 3 times 4 divided by 3. The 3's will cancel out, and I'll just be left with this -4. So I know my final answer here is -4x, and I'm subtracting a power to the power of 2. All right, moving on to 13. What house are we in? We are in E house. So E house means I'm rewriting the equation, ex to the power of 2, and then I multiply by dinner. Dinner in this case is x squared is inner, so dinner is 2x. So this is the same thing as, I'm just changing the order here, 2x e to the power of x to the power of 2. All right, number 14. We have our f of x is equal to this. What house are we in? We are in E house. So E house means I'm rewriting the entire equation. So this is going to be equal to be to the power of x, and multiply that by dinner. Well, inner is x, so dinner is 1. So I don't even have to multiply by 1. That is the answer. Moving on to number 15. All right. Find the derivative of x to the power 4th. What house are we in? We are in power house. So power house means I'm going to bring that exponent down and multiply it, or make that the coefficient, 4x, and this number gets subtracted by 1, 4x to the power of 3. All right, let's look at 16. What house are we in? We are in E house. So E house means I rewrite the equation. So this is going to be e to the power of square root of x. Now inner here is this square root of x. And remember, square root of x is equal to x to the power of 1/2. So what is dinner? This is inner right here. So dinner is, I'm going to multiply this by dinner. Dinner is 1/2 x to the -1/2. Maybe I can say that that was our aside here. So continuing on the problem, this thing, now simplified, is equal to e to the power of square root of x. All of this is being divided by 2 square root of x. And I feel like there's going to be 1 or 2 people saying, wait, how did you get that? So I did a few steps here. First of all, I knew that 2 was in the denominator, so that's where the 2 came from. X to the -1/2 is the same thing as saying x goes in the denominator, putting x down here to the positive 1/2. And then the 1/2 just means square root, so that's where the square root came from. And that's the reason it's in the denominator. E to the power of square root of x is still in the numerator. All right, number 17. What house are we in? We're in E house, which means f prime of x, I'm just going to say this f prime of x is equal to e to the power of 2x over 4. I rewrite my E house. I rewrite the equation. And now I multiply that by dinner. Well, inner is what? Inner is 2x, so dinner is 2. And that simplifies to the 2 and the 4, this will be e to the power of 2x divided by, you should have got it, 2. All right, number 18, here we go. What house are we in? We're in E house. So E house means I rewrite the equation. So negative 5e to the negative x, multiply that by dinner. Well, what's inner? We have our negative x. So dinner is negative 1. Rewrite this. This is equal to 5e to the negative x. If I wanted to write this with positive powers, it didn't really say to do that in the instructions back here. There were no instructions, so we can assume that we're fine. I mean, the problem gave us a negative exponent. We can leave it as a negative exponent. We could write 5 over e to the power of positive x, but I don't think we need to do that. All right. d dx, the derivative of negative 1. What house are we in? We're not even really in a house. I mean, you can maybe say you're in powerhouse, but this is the rule that we need to know. Derivative of a constant, derivative of a number. Derivative of a constant is always 0. All right, so here we go. Our function is negative e to the power of x plus 1. What house are we in? Yep, you got it right. It is E house. You should be getting all of these by now. It's pretty clear. It's either E house or power house. Log houses are our next page. So E house, we rewrite the problem, right? F prime of x, this is equal to, it's going to be equal to negative e to the power of x plus 1. I just rewrite it and multiply that by dinner. Well, what is inner? Yep, you got it right. It's x plus 1. So the derivative of the dinner is 1. So I'm not even going to write that times. It's just times 1. So that is the answer. All right. Let's look at d dx of the derivative of this function. What house are we in? You got it. It's E house. So E house means I'm rewriting this. E to the power of negative 4x to the power of negative 1. Oh gosh. Okay, we know what our inner is. Our inner is this guy, negative 4x to the power of negative 1. So what is dinner then? The derivative of the inner. So derivative of the inner is going to be, this is technically another powerhouse up here. So it's going to be E house to the powerhouse. So we just did the E house rule. Now powerhouse rule means I'm going to multiply this negative 1 down to the negative 4, and that's going to be a positive 4. And then I have my x to the power of, remember negative 1, I subtract 1 again, to the power of negative 2. So just simplifying this, you just kind of squish it all together. You can say that this is 4x to the negative 2 times e to the negative 4x to the negative 1. And you could just write this e, this exponential function in the denominator. But I'm going to leave it like this since it gave us a negative power to begin with. All right, number 22. What house are we in? Yes, we are. We are in E house. So E house means we rewrite the problem for the doubter. Doubter is always the same thing when I'm in E house. Doubter is the same as a function. All right, this is going to be hard to write. Make sure I get all of this. Negative 6 over x to the power of 3. Hopefully you can see that. It's kind of hard to see with my pen being so thick. I can maybe make it skinnier. All right, so we have doubter. Multiply doubter by dinner. What is inner? Yep, it's that guy. Inner. So dinner is what? And dinner, we're going to have to take an extra step here because I'm going to make a note maybe on the bottom left down here that when I have negative 6 over x cubed, in order to take the derivative, and this is a review of yesterday, when I have a fraction like this, we can't take the derivative without using a quotient rule, and I don't want to use a quotient rule. We haven't actually learned that yet. So I rewrite this as, giving you time to think to make sure you know this, rewrite this as negative 6x to the negative 3. Now we can take the derivative of that thing. Now we can say that is going to be multiplied by, and this is now what house? This is, yes, powerhouse, you got it. So negative 3 comes down, so this is going to be a positive 3, x to the, and then I subtract power, minus 4, and I'm running out of room. I'm going to do it. I'm going to say, hey, don't run into that. So this whole thing is equal to, now I'm going to multiply all this together. So I have a 2 times 3, which is a 6. I'm going to do the x's first and then the e's. So I'm going to say 6x to the negative 4. And, oh, actually, they gave it in as a positive power. So I'm going to not write 6x to the negative 4. I'm just going to throw that in the denominator. I'm going to say x to the, actually, this was a negative exponent. I'll just leave it up here. Okay, 6x to the negative 4, and then e also to a negative power, e to the negative, and you can write it as negative 6x to the negative 3, or you can write it as they gave it to you, which is 6 over x to the third power. All right, that one was a challenging one. Let's try number 23. F prime of x. F prime of x. What house are we in? Oh, Mr. Sindel, there's two things. Yes, there's this guy and then there's this guy. Whenever you have things that are added together, it's kind of like our polynomial rule. You just take the derivative of the one and then use the same sign with the derivative of the other. So take the derivative of this one, add it to the derivative of this one. Our first term is what house? Yeah, it's e house. You guys got it. So this is going to be negative e to the x plus 1. I need to multiply that by dinner. All right, inner was x plus 1, so dinner is... Yes, you got it. It is 1. So I actually am not going to write times anything. So we got daughter by dinner. That is daughter by dinner of the first term. And I'm going to add that to daughter times dinner, which is just really daughter. This is just powerhouse here. Powerhouse means 3 times 2 plus 6. And then x goes to the power of 1 minus, or this guy minus 1, which is 2. And there's our final answer. All right. I believe we're on the next piece of paper. Here we go. Number 1, we are officially doing log houses. Here we go, natural log. So what is our outer? Our outer is 2 times the natural log of something. So daughter is then 2 over that same something. Inner is x cubed, so dinner is 3x squared. So just multiply daughter by dinner. What is daughter? It's 2 over that something. Well, what is that something? That something is x cubed. And dinner, multiply daughter by dinner. Dinner is 3x squared. All right, go ahead and simplify this. So the first simplification step I have, numerator is 2 times this guy, so it's going to be 6x squared. Denominator is just x cubed. And we can simplify this one more step. You can see that this is clearly 6 over x. This power is 1 greater than this one, so that's where the x comes from. If there are questions about this, you can ask me after class or before class or lunch. Just ask me. All right, here we go. Number 2, the outer. Outer is natural or negative natural log of something. So daughter is negative 1 over that something. The inner is going to be x. Dinner is going to be 1. All right, daughter times dinner. Negative 1 over that something. What is that something? That something is x. By the way, if there's no parentheses, you can assume it's whatever is directly after the natural log, to make myself clear here. Okay, we got the daughter. Dinner is 1. Final answer is negative 1 over x. All right, moving on to number 3. Let's whip these out. Okay, so natural log of this. What house are we in? What house are we in for almost all of these? All of these are, yeah, every single one of number 3 through 11 are log house. So I'm not even going to ask that question. We know we're in log house for this entire side. So we're in log house. So outer is the natural log. So outer means I'm going to be taking daughter. Daughter is going to be 1 over something, and that something is 3x squared. So I just did daughter. Now I'm doing dinner. Dinner is 6x because dinner is powerhouse. In fact, are all of these inners going to be, looks like all these inners are going to be very related. I don't see any inners with an exponential function. So our final answer here is going to be, I'm going to simplify all at once. Let's see if you guys can catch what I'm doing here. This is going to be 2 over x. You guys see what I did? The 6 and 3 make 2, and then the x divided by x squared gives just x in the denominator. Cool. All right, let's do number 4. Again, I'm making sure that you understand the instructions. Pause me. I don't want to just run through all of them and give them to you. Do them yourself and then use me to check your work. Here we go, number 4. So my outer is negative 2 natural log of something. So that turns into the daughter, which is negative 2 over that something. That something was x. I just did daughter, multiply daughter by dinner. Dinner, well, what's inner? Inner is x, so dinner is 1. Final answer is negative 2 over x. All right, here we go. Number 5. We have another log house, so let's do this. Log house, the outer is just basically divided by -3, essentially. So I have this one can be a little bit confusing because usually you just say, oh, just shove everything in the denominator, but we already have a denominator because let me label this to make sure we clearly understand this. The outer, this guy is negative natural log of something over 3. So when I'm taking Doubter, this is what I'm doing. Doubter is going to look like this. It's going to have that negative still. It's going to already have that 3. So that's the basic setup. I rewrite the outer, and now I'm taking the derivative, I'm making it Doubter, and I divide by that something. There's dividing by that something. And maybe I should make this bigger. That something is what? That something is 2x. So there is Doubter. Now I'm going to multiply that by dinner. Well, what's inner? Inner is 2x, so dinner is 2. My final answer is -2. Oh, wait, I can simplify this. I'll do it in 2 steps. -2 over 6x. And that simplifies one step further into -1 over 3x. Doubter times dinner, over and over. Here we go. Number 6, log house again. So my doubter is -1 over that something. What is that something? The inner is -x. Oh, you might see that this can be simplified. There we go. Okay, we'll do that in a sec. Let's multiply this by dinner. Inner is -x. So dinner is -1. Lots and lots of negatives. You should see that the final answer here is -1 over x. All right. So here we go, number 7. We take the natural log of 5x. We're in log house, so let's do doubter. Doubter is 1 over 5x. Dinner is 5. Simplify 1 over x. All right, did you catch everything there? 5 over 5 simplified to 1 over x. All right, cool. That was a nice, sweet, smooth problem. All right, number 8, here we go. Log house again, this time with a variable. So our variable is testing us here to make sure we know what we're doing. Log house, here is the doubter. Doubter is a, stays in the numerator, and then everything in here goes in the denominator. A over the inner is x squared. So that was doubter. Now I'm going to multiply by dinner. Well, inner was, what was that? What was inner? Inner was x squared. So dinner is 2x. So this turns into, and I'm going to go ahead and simplify it all at one step. Make sure you can follow this. 2a over x. Because x and x squared cancels out, and you get an x. Well, they don't both cancel out. The power cancels out. All right. And here we go. Number 9. Make sure you're pausing me in between each problem, unless you've done all of them already, I guess. So here we go. What is doubter? Doubter is 5 over, okay, so this is how I'm going to make sure I do this correctly. 5 giant fraction over x over 5. So that was doubter. The 5 was left on the top, and then the inner is x over 5. Inner goes on the bottom. This is multiplied by dinner. And dinner is, you might think, oh, you need to use a negative exponent or something. No, that's not the case. This is really just the same thing. Let me write this in my notes over here. I'm going to write it up here so it's out of the way. This inner is just 1/5, which is like a number like 2 times x. So 2 times x, the derivative of that is just the coefficient in front. So the dinner here is going to be 1/5, just the number in front. All right, so this actually simplifies pretty cool. So the 1 is going to be multiplied with 5. So let me write some notes here. The 1 gets multiplied with 5. I know fractions can be a little bit confusing. 1 gets multiplied with 5, and then the 5 gets multiplied. Okay, my arrow is not going to the right place. The 5 is getting multiplied by this entire fraction. So this is really 5 over 1. So I'm going to write it out in 2 steps just to make sure we see what's going on. This is going to be 5 times 1. There's the 5 times 1 divided by x over 5 times the 5, which is really 5 over 1. And this is going to be equal to, I'm running into the space of number 10, 5 over x. Pretty cool. Simplified that far. All right, so I'm going to do a little squiggly line. We're on to number 10. All right, so natural log squared of x. So this one, you have to be careful because it's not exactly clear, unless you've dealt with these a lot before, what it's asking for. This should be rewritten as, I'm not even going to take the derivative yet. I'm just going to rewrite this problem as d dx of Okay, here we go. I need to write this correctly. D dx, the derivative of natural log of x, and then I need to take all of that and square it. This is how it should really be seen, although this is the correct mathematical notation of what I'm doing. So I'm really doing an outer, an inner, and an inner. I have to check all three of them. This is 3 embedded in 1. So the outer, is just parentheses squared. Outer is actually a powerhouse. So I was wrong when I said all of these are only log house. This is a powerhouse, and then the inner is a log house, and then the inner is x. Okay, so let's go ahead and take dinner. Sorry, we're taking doubter first. Doubter is derivative of outer. Outer was this something squared. So doubter is going to be 2 of that same something squared. 2 of the same something. 2 of natural log of x. And then I subtract power to power of 1 right here. But I'm not going to write it. So I just did doubter. Now I need to multiply it by dinner. Remember, inner is natural log of x. So dinner is going to be 1 over x. And then inner, remember x is now the inner. So inner is going to be 1. So I'm not going to write that here. I guess I can write it. Times 1. So all of this simplifies to, and I have enough space, I think you guys can see me down here. This simplifies to 2 times natural log of x divided by x. And you might think that maybe these x's can be simplified. No, because this is really natural log of x. It's like saying sine of pi. The pi is a dependent that goes into the function, so you can't actually cross those out. You just leave it like this. This is the simplified version, 2 natural log of x over x. All right, number 11, here we go. So here's our function. We need to find f prime of x. All right, so all we're doing, doubter times dinner. So outer is natural log, so doubter is going to be 1 over whatever was inside the parentheses. 1, I'm going to make this really big, and then inside the parentheses was 1 over x squared. So that was doubter. And now I do dinner. So again, we have to do something similar to what we did on a previous worksheet, where we can't take the derivative of 1 over x squared. 1 over x squared. D dx. Right now I'm finding the dinner. D dx of 1 over x squared. You can't do this yet because it's a fraction. You have to de-rationalize it. Do you remember how to de-rationalize this guy? This is equal to, my equal sign got a little bit wonky there. This is equal to the derivative of x to the negative 2. Now I can take the derivative. So now I can find dinner down here, which is this guy. Dinner is negative, I'm multiplying here. I'm multiplying by negative 2x, and now I subtract a power. Negative 2 minus 1 is negative 3. All right, now I need to simplify this guy. Here we go. So on the top I have, actually this all can be written on the denominator too. So on the top I just have the negative 2. In the numerator, just negative 2. And, oh, that's not quite the case, because this 1 divided by x to the power of 2, that's actually going to flip the x squared into the top. And if you can't see what I mean by that, I'm going to write out in a few steps. So first, let's get this guy out of the way. Negative 2 divided by x to the power of 3. All I did here is I took dinner and I wrote it in a different form. You guys hopefully can see that. Now I'm going to rewrite this guy in a different form, and then I'm going to do one more step after that. So let me, oh, whoops, that's not what I meant to do. Let me undo a few things to make this line less big, because I need more room. So this is going to be divided by x to the power of 3. And this is going to be multiplied by my inner, or my doubter. This is all my doubter. So this is going to be rewritten as 1 over x to the negative 2. All I did was I took this fraction, took it to the negative 2. And when I flip it up to the numerator again, it turns positive, which is going to be my final, let's see. I'm going to do 2 steps here. Let's see if you guys can follow me. I'm going to flip it up here to make the power positive. So I'm going to have x squared on the top, and then it's going to simplify with the bottom. So it's going to be negative 2 over x. So again, this x to the power of negative 2 flipped up to the numerator to be x to the power of positive 2, and then x to the power of positive 2 divided by x to the power of 3 cancels out to become just 1 over x, and I still have the negative 2 to deal with. So that is my final answer for number 11. All right, we have a few more problems left, so let's get through them. Number 12, here we go. So this is going to be the derivative of this function. What now? We have to figure out what house we're in. So what house are we in? We are in power house. Power house means I multiply this 2 down in front, and I'm going to do this all in one step. Let's see if you guys can follow me here. All in one step, the 2 gets multiplied in front, so I get a negative 3x to the power of 1. So that's my final answer. Again, the 2 and 2 cancel out. That's where the 2's went. Where did they go? All right, so what house are we in for number 13? Number 13, we are in actually 2 houses, right? We're first in E house, and then we're in power house. So we're going to have an outer, an inner, and an inner. So here we go. Actually, the inner is 1, so maybe we don't have to worry about it, but here we go. So doubter. Doubter is just the same thing. Whenever we're in E house, you just rewrite it. Doubter is e to the power of x to the power of 3. Now multiply that by dinner. Well, the inner was x to the power of 3, so dinner must just be, it's a power house rule. Make sure you get it. It is 3x squared. This simplifies to 3x squared x to the power of 3. All right, number 14, here we go. What house are we in? We are in log house. So log house states it's 1 divided by whatever's in parentheses, 1 divided by 10 divided by x. All right, so f prime of x is equal to all of this. And then this whole thing can be written as 1 divided by 10x to the negative 1, which then gets rewritten as x divided by 10. All right. I'm just playing with rules of negative exponents. Keep jumping up ladders, keep jumping up rungs, changing negative and positive with each rung that you jump up. All right, 15. What house are we in? You are correct. It is power house. So power house is a pretty simple one. This is just 2x, and we don't even have a dinner. We just have doubter. Number 16. What house are we in? We're actually in 2 houses. The first house that we're in is E house. Second house is power house. Remember that square root of x, just a reminder that square root of, this is not actually equal to, this is a side note. Remember that square root of x is x to the power of 1/2. So from there, we know that this problem is doubter. Doubter we have just, if it's E house, you rewrite it, right? Doubter is e to the power, 2e to the power of square root of x. And I multiply this by dinner. Well, inner was this guy. So dinner must be 1/2 x to the power of negative 1/2. So this whole thing can be rewritten as, this equals e to the power of square root of x divided by square root of x. I did skip a step there. Let's see if you can follow it. X, the 1/2 and 2 got canceled out, obviously. The e to the power of x is still in the numerator, and this guy shifted to the denominator to make it a positive power. So it was 1 over x to the power of 1/2, and then 1 over x to the power of 1/2. Now the x to the power of 1/2 is down here. It is square root of x. All right, here we go. Number 17. F of x is equal to this guy. What house are we in? You are correct. We are in log house. So f prime of x, the derivative here is equal to 1 over whatever was inside the parentheses, x plus 2. All right, and what is dinner? This was doubter. Dinner was 1 because derivative of this inside is 1. So this is my answer. Almost there, just a few more problems left. Let's get through these all the way to 23, and then we're done. So we have 18. What house are we in? We're in E house. So doubter is going to be the same as the function. Doubter is negative e to the negative 2x. What's dinner? Well, first, what's inner? Inner is negative 2x. So dinner must be negative 2 for a final answer of 2e to the negative 2x. All right, 19. The derivative of 1. What is that guy? It's the derivative of a constant. Derivative of a constant is always, yep, you got it, 0. All right, ooh, here we go. We have log house inside of a log house. So I'm going to do this outside log house first. So outside log house, doubter is going to be 1 over whatever was inside parentheses. So doubter is going to be 1 over natural log of x. Okay, this is going to be multiplied by dinner. Well, inner is natural log of x, so dinner is going to be, again, 1 over whatever was inside the parentheses. What is inside the parentheses for, let me scribble this out. What is inside the parentheses for this function? Inside parentheses is x, so it's going to be 1 divided by x. 1 divided by x. And this just simplifies to 1 over x natural log of x. And this is, by the way, f prime is equal to this guy. Number 21. We have derivative of this house. This house is, it is e. E house, yes. So when I take e house, I do Dowder times dinner, and Dowder is always the same. Dowder is always the same for e house, e to the negative 4x. All right, what is inner? Because we need to multiply this by dinner. Inner is, yep, it's that negative 4x. So dinner must be negative 4. Therefore, our final answer is negative 4 e to the power of negative 4x. All right, let's take a look at number 22. What house are we in? Fraction house, Mr. Sindel. No, there are no fraction houses, not until we get to quotient rule. Rewrite this guy. So I'm going to say in my notes here, in a different color, that negative 6 over x to the power of 3, this is equal to something that is not a fraction. Go ahead and do it. All right, you've unpaused. So it is negative 6x to the negative 3. So that means that if I'm taking the derivative of this function, this is powerhouse. And powerhouse states that you do negative 3 multiplied down by the coefficient. Negative 6 times negative 3 is a positive 18. So this derivative is equal to, and I'm going to do a little arrow here to make sure I'm not confusing anyone. This derivative is now equal to 18x, and then I do x, the exponent, subtract 1 to the negative 4. And since they gave us a positive exponent, I'm going to leave this as a negative exponent, or leave it as a positive exponent in the same form that I found it, and this is equal to 18 divided by x to the power of positive 4. All right, our last problem for the homework. Here we go. This is our function. It's equal to the natural log of this guy. So we are in a bunch of different houses here. First house is log house, and I see inside here we have a bunch of things that are being added and subtracted, so we'll do each term independently for that inner. All right, so outer is natural log of all this. So Dowder is going to be 1 over whatever was in parentheses, which is a giant thing. So 1 over this giant parenthesis is 1 over x minus 2 plus e to the negative 2x. I just did Dowder. Now dinner. Dinner. This whole thing here is going to be dinner. Dinner is going to be 1, derivative of x is 1, minus derivative of a constant is 0, plus derivative of this thing, we are in E house. Oh my gosh, and this E house has an inner in itself. So we have an outer inner and an inner. So I'm going to get ready to multiply this by the inner, or dinner inner, because the derivative of inner. So this is going to be times, or I'm going to do 0 plus derivative of this thing. Derivative of E house is just itself. So derivative of E house is e to the negative 2x. And now I need to do the inner. Inner is negative 2x. So the dinner inner is negative 2. All right, let's write all of this simplified. Here we go. All of this simplified is going to be, and I'm going to go ahead and distribute this negative 2 to make it look nice. So this is going to be negative 2, and I'm doing the numerator right now. Negative 2, I just distributed this term. I don't have to worry about the 0, and I'm going to do minus 2e to the power of negative 2x. I just distributed this negative 2 into the numerator, and now I'm going to rewrite the denominator. I don't have to change anything. This is going to be x minus 2 plus e to the negative 2x. That is my final answer. All right, that concludes the homework solutions. Thank you for watching.